Chapter 4, Section 9, Missing Data Imputation, Part 3, Data Leakage. Data leakage is a problem that can occur during the data preprocessing stage when building a supervised learning model. If data leakage is left unaddressed, the prediction model's performance may be reduced. This lecture will first explain the hold-up method as a prerequisite knowledge for understanding data leakage. I will then explain what data leakage is, why it occurs, and why it is problematic. Next, I will talk about how to prevent data leakage. In supervised learning, the prediction model should have high generalizability. Generalizability refers to a model's ability to adapt to new, previously unseen data. So, a model with high generalizability should achieve high performance not only for existing data, but also for newly unseen data. The purpose of predictive analytics is to build a model that can predict new data accurately. Therefore, predictive model should have high generalizability. So, even if the model makes perfect or almost perfect prediction for existing data, it is useless if it performs poorly for new data. On the contrary, even if the model's performance is slightly lower for existing data, the model is useful if it achieves moderate or high performance for new data. In developing a supervised model, one of our greatest concerns is to prevent overfitting. Overfitting is a phenomenon where a prediction model makes accurate prediction for a particular dataset, but poorly works for additional data. In other words, overfitting refers to a modeling error, where a prediction model fits too closely to a particular dataset, and thus poorly fit other unknown datasets. Overfitted model only memorizes a particular dataset, but it does not learn underlying pattern in data. So, overfitted model is not generalizable. There are various methods to prevent overfitting, but the most basic one is to collect more data for model training. It is because, generally, the more samples a dataset contains, the more representative the dataset is. To evaluate a model's generalizability and check the degree of overfitting, we can use a method called hold-out method to train and test a prediction model. Model training is a machine learning jargon that means developing a model using data so that the model can achieve high performance. Model testing is the process of evaluating the model's prediction performance on unknown new data. In model training, using hold-out method, we split existing data into training data and test data. The training data is existing data, and the test data is hypothetical new data. We develop predictive models to predict future data. However, future data is not available when we are developing a model. Therefore, to test whether the model we are developing now is likely to demonstrate high predictive performance with future data, a portion of the already obtained data is set aside to be used as hypothetical future data for performance testing. Usually, around 70 to 80% of the whole data is used for training, and the remaining 20 to 30% is used for test data. Next, we train the model using the training data to make the model learn underlying pattern from data. After the model training, we evaluate the model's prediction performance. That is, we quantify how accurately the model predicts the outcome for the training dataset. Next, We apply the trained model to the test dataset and evaluate the model's prediction performance. Since test data is hypothetical future data, performance evaluation using test data is a process that virtually evaluates how accurately the model can make predictions for future data. We need to compare the model performance between prediction for training data and that for test data. If the model achieves high prediction performance both in training and test datasets, we can say the model has high generalizability and our model training is successfully completed. But if the model performance is much lower for the test set, the model's generalizability is low. That is, when a model performs much worse for test data than for training data, the model overfits the training data. Data leakage refers to a phenomenon in the machine learning training, where the model accesses information about future data or test data that should not be accessed during training. When data leakage occurs, the model becomes overfitting and shows a naturally high performance. However, this performance cannot be reproduced in the actual operating environment. Specifically, the major problem is that the information from the test data that should be set aside for model evaluation is used for training in the training phase. This leads to incorrect model evaluation, overestimating the model's prediction performance. In developing a supervised learning model, data leakage will occur if we impute missing values before splitting the training and test data. The test data should be treated as hypothetical future data in supervised learning. So, using information from test data for preprocessing means using future information during model training. It is not realistic. Training a model in this way means training the model with information from the test data. So, there is a possibility that the prediction performance on the test data will be overestimated. For the reasons given above, when developing a supervised learning model, we should split our data into the training data and test data, and then performing missing value imputation separately. For the training data, we should impute missing values using only the information in the training data. Note that for the test data, we should do it using information from the training data, not from the test data. Let's look at the workflow. First, split the data into the training data and the test data. Next, impute the missing values for only the training data. We should do it by using the information from the training data. For example, when performing mean imputation, the missing values are imputed using the mean value, calculated using the training data only. Next, impute the missing values for the test data. We must impute the missing values for test data using the information from the training data. For example, to impute the missing values in the test data, we should use the average value computed using the training data, or the KNN model developed using only the training data. Let's look at the simple example of mean imputation. For simplicity, let's focus on just one variable, satisfaction level. There are three missing values. First, let's look at the erroneous example. We calculate the average value for the entire dataset. We then use this average value to impute the missing data. This method is inappropriate. If we were to use these two data points as test data, The missing data in the training data will be imputed with the information that contains the information from test data. Let's look at the correct example. First, split the data into training data and test data. We use the 8 data points above as training data, and the 2 below as test data. Then, we calculate the average using only the training data. This average value is used for imputing the missing values in the training data. As an important point, the average value of the training data is also used to impute the test data. Thank you for watching. If you have any questions, feel free to ask in the comments. Your feedback is always appreciated.